people have always tried to comprehend the world around them. Today, we learn about the world not only on Earth, but also far beyond the solar system and even our galaxy. Thanks to this, we've discovered countless celestial bodies. For sure, our universe has all kinds of cosmic objects. So, let's take a trip to see the most unusual ones. We'll begin our journey with the largest void in the universe. It is so huge that time inside seems to stop. Next, we are going to visit the stars inside our galaxy whose very existence seems implausible. They keep everyone puzzled and leave us with more questions than answers. Next, we'll take a trip beyond the Milky Way to see zombie galaxies. Do you want to find out what it is? 2 of the stops will be deadly magnetars that can extract iron from a person's blood, being thousands of kilometers away, and black holes whose very existence is frightening. This is an epic journey to the most unusual space objects. Imagine a place where there is nothing for millions of light years ahead. Absolutely nothing, total darkness. A place so dark that it seems that time itself is put on hold. But what is it? Let me explain. We know that we orbit the Sun and the Sun orbits the center of the Milky Way galaxy. The Milky Way, along with its 50 neighbors, goes around the invisible gravitational center in the local galaxy group, located inside the Virgo supercluster. Just like other superclusters, it turns out to be a part of a much bigger Laniakea supercluster. Inside the circle, the objects don't orbit the same point but gravitate towards a super-heavy great attractor anomaly in the center. We can't see it due to the specific location of our galaxy. Our galactic disk obstructs our view. But today, we're interested not in the attractor itself, but the eerie empty space in front of it, the dipole repeller. Such empty areas in outer space are called voids, and if you look at the universe from the outside, it would seem like an infinite network of galactic threads divided by empty spaces called voids. This is what our world looks like if you could capture it in one picture. 10 billion light-years connected with galactic threads. Voids are one of the biggest structures in nature that occupy most space in the universe. Today we will focus on one of these voids, the Boots void. When we gaze at the stars, it seems that they are dispersed evenly throughout the sky. But this is an illusion, as all stars are in galaxies, located relatively close to each other, making gravitational clusters. But the emptiness created between them is nothing compared to the scale of the void. The Boots void is one of the biggest voids in the whole universe. It is located 700 million light-years away from our planet, near the Boots constellation, from which it borrowed its name. The Great Void was discovered in 1981 by Robert Kirshner and his team. For many years, scientists have been asking themselves about the nature of this void, how it was created, and what exactly lurks in the darkness. The diameter of the Boots void is estimated to be 330 million light-years, which is astonishing considering the fact that it comprises 0.27% of the diameter of the known universe. The size of our Milky Way galaxy is about 100,000 light-years, which is minuscule compared to this void. When scientists first started to study the void, they discovered 8 galaxies. This is very little compared to other gravitational clusters which have already been explored. Before long, 52 more galaxies have been discovered at great distances from each other. According to astronomer Greg Aldering from the University of Minnesota, the scale of the void is such that if the Milky Way had been in the center of the Boots void, we wouldn't have known there were other galaxies until the 1960s. They would have been so far away that they would have been invisible to the telescopes that existed up until the 60s. At that point, our telescopes got good enough that if we had been in that void, we would have been able to see the dim light from the other galaxies and begin to fathom their existence. So far, only 60 galaxies have been found in the Boots void. Using a rough estimate of about 1 galaxy every 10 million light-years, 4 times as far as the Andromeda galaxy from Earth, there should have been approximately 2,000 galaxies in the Boots void. Upon discovering this great void, astronomers have noticed how mysterious and unique this area is. When taking into account the distance between the galaxies inside the void, it's clear that it can be called a paranormal area. Just to put this in perspective, our Milky Way galaxy has around 24 neighbors in the space of around 3 million light-years in the cross-section. Taking into account that the average distance between galaxies in the universe, the nature of the Boots void gives us a lot to think about. Needless to say, the void's visitors would be, at the very least, shocked to see this isolation, extreme distances between galaxies and pitch-dark space. Moreover, the Boots void is probably the most ideal vacuum in outer space, so we should study its effects. Dirt and dust would be rare to come by in this space, as would even particles. It would take thousands of years for the particles to interact. That is, if the interaction could ever happen in the first place. This extremely low density means that when a pattern of neutrinos enters one side of the void, it looks exactly the same upon exit. The same goes for photons. Particles of matter, having much more mass than both photons and neutrinos, would of course get pulled towards the walls of the void. Because of this state-preserving property, the Boots void may one day be seen as the ultimate time capsule. Fire off a pattern of photons, only for the pattern to be rediscovered hundreds of millions of years later when it reaches the other side. Perhaps the Boots void will serve as a proving ground for the high-speed dragsters of the future, moving at 99.99% the speed of light. Its extremely low density would certainly be appealing to anyone who wants to set speed records without intergalactic dust getting in the way. Of course, scientists are keen to know how this paranormal area came to be. The Boots void is a unique place that cannot be compared to anything within the known universe. Some scientists argue that the Great Void was created when several small voids came together. Even though this idea is hard to comprehend, it's completely plausible, taking into account the nature of space. This phenomenon resembles small soap bubbles coming together. Astronomer Greg Aldering once noticed that the galaxies located in voids have a curiously tubular structure, which can be an important clue. It was him who suggested that the void can come together much like soap bubbles merging into one great bubble. As for the tubular galaxies, these might be the remnants of the borders between the smaller voids. Those galaxies are stranded now inside a supervoid, but if the universe lasts long enough, they may get cleared out of it, says Aldering. The long arm of gravity never quits. There is another, albeit more radical, possibility, and one that has likely not been considered in the scientific literature. The Boots void could be the result of an expanding Kardashev-3 scale civilization. As the colonization bubble expands outward from its home system, the civilization dims each star, and subsequently each galaxy it encounters, by blanketing it in a Dyson shell. This might also explain why the void has such a nice spherical shape. Given that the void is about 700 million light-years from Earth, and that intelligent life could have emerged in the universe about 4 billion years ago, this ancient civilization may have had enough time to perform this astonishing feat of cosmological engineering. Now, this is pure speculation, but it's worth throwing it out there as a possibility given the strangeness of this phenomenon. Needless to say, the discovery of the void has thrown conventional cosmological thinking out the window. Since its discovery, astronomers have had to revise their notions of galaxy formation, given what we now know about the extreme non-uniform distribution of matter throughout the universe. Finally, the Boots void provides another humbling reminder of the vastness and sparseness of the cosmos. The universe that we see is too impossibly large for us to comprehend. Our place within it is a tiny, insignificant, microscopic spark. But all that said, and as alone as we may appear here on Earth, at least we have a starscape to gaze upon when we look up into the night sky. Now let's discuss the HD 100 and 1065, or Chebyshev star. This star is highly unique due to its spectrum. Everyone who has seen it claims it was one of the weirdest star spectrums they have ever come across. A spectrum reveals which elements a star contains. The stumbling block for the researchers was that they couldn't get comprehensive data on how many elements it contains. Some scientists talk about an infinite number of lines which makes them impossible to study in detail. How can this be? Astronomers have studied the Chebysky star since the 1960s, but to this day, they have no idea what elements it consists of. One theory suggests this might be because it contains elements and isotopes scientists have never discovered in nature. The data was obtained using one of the methods which connects the type of light emitted by a star with elements it contains. The results made scientists realize their previous conclusions concerning the contents of HD 100 and 1065 were inconsistent. First, it appears from the spectrum that it contains almost no iron, which is means that if those elements aren't new compositions or they aren't being replenished, they should have completely decomposed by the time when people appeared and learned how to use telescopes. So far, there are several possible explanations. Astronomers argue that these atoms could have appeared as a result of creating a supernova or current reactions catalyzed by a neutron star close by. Unfortunately, very little data support these theories. However, there might exist another possible explanation, which has nothing to do with the latter. Chebysky star might contain some super heavy elements and isotopes which haven't been discovered yet. After some time, these super heavy atoms can break down into short-living isotopes that we can observe. In particular, these atoms can belong to the following three elements: fluorovia, unbehexium, or unbenellium. Scientists have managed to create as few as 100 atoms of fluorovium in the laboratory setting. As for unbehexium and unbenellium, they exist only in theory. We haven't yet discovered any of these elements in nature. If the described theory is correct, studying Chebysky star will enable us to explore these elements in real life. There is a slight chance that isotopes inside this heavenly body are a part of the so-called Stability Island, a hypothetical group of super heavy and super stable elements which have long been pursued by scientists. But today it's clear that everything is not that easy. Thanks to the scientific findings, we know that Chebysky star belongs to a special type of A-stars, or chemically peculiar A-stars. As a rule, regular A-type stars are hot and don't have a magnetic field, but A-stars are cold on the surface. They have a strong magnetic field and quite long rotation periods. For some reason, these stars contain lots of lanthanides and little iron. So this means the Chebysky star is not that unique after all. As if strange chemical composition wasn't enough, Chebysky star is noted for its unusual movement pattern. A new analysis led by researchers from the Leibniz Institute for Astrophysics in Potsdam, Germany has discovered that HD 100 and 1065 isn't just composed of bizarre stuff. It also exhibits bizarre movement. A team from Chile discovered that the star's rotation period stretches out over 188 years. Our analysis of newly acquired and historic longitudinal magnetic field measurements indicates that Chebysky star is also unusual with respect to its extremely slow rotation. The researchers state that's a pretty long time for a star to do a 360, although slow rotation could be considered normal for A-stars. As I mentioned earlier, there is a chance that we've misinterpreted some information, which means that the Chebysky star doesn't contain short-living isotopes after all. This star's spectrum is difficult to identify. Spectrums usually have several relatively clear lines that correspond to various elements. But when it comes to this star, such lines occur almost everywhere. This has sparked a lively discussion as to what goes on, which continues even today. There is a questionable, but quite popular theory which suggests that the star's composition resembles the products of artificial nuclear fission. Back in 1980, American scientists Daniel Whitmire and Jason Wright suggested that extraterrestrial civilizations can use their stars to store nuclear waste. They even pointed out that type of stars, such as Chebysky star, are most probably where this waste can be found. Such short-living, apparently artificial elements and A-type stars can be really seen as evidence of an artifact of a well-known SETI program. Rest assured, we will find an answer to the question of how these elements appeared on this star. Nonetheless, we should keep on trying to reveal this mystery, because even if a SETI artifact won't find the evidence of the existence of extraterrestrial civilization, these findings will be of great interest to the scientists. Quite recently, scientists came up with a hypothesis that can explain the anomalous chemical contents of the star. It is based on the fact that a neutron star influences the atmosphere of Chibylsky star, with which it makes up a closely linked system. Theoretically speaking, this hypothesis can be feasible. However, there's a big caveat. There are no neutron stars around. Indeed, scientists from the University of South Wales hypothesize that actinides in Chibylsky star can be the evidence of slow degradation of super-heavy elements. The theory posits the existence of a so-called stability island that includes elements with a nucleus containing 114 or more protons. These are super-heavy elements, but at the same time, they are long-living. If we hypothesize the existence of such elements, then short-living plutonium, Einsteinium, and other elements found on this star will simply be 20 kilometers, which means that this star is the size of Manhattan. Its big mass, coupled with a small size, ensures extremely tight density. Just imagine, neutron stars are so dense that one spoonful of this star's matter would weigh about 1 billion tons here on Earth. Breathtaking, isn't it? Chu 1719-1438 is a neutron star with an extreme rotation speed. It is also known as a millisecond pulsar. It rotates around its axis over 10,000 times per minute. This means it takes only 5.8 milliseconds for the star to complete one rotation. Millisecond pulsars emit high-precision impulses, making them very sensitive to probes. After some time, any object orbiting such pulsars causes regular Doppler shifts in impulses, which enables us to ascertain the presence of a companion and to precisely measure the orbit size and the object's mass. In general, around 70% of pulsars have companions of different types. It is a companion which makes the mystery of the star so beguiling. Its name is PSR J1000, 719,438 bits. It is as heavy as Jupiter, but its diameter is 2.3 times smaller, about 60,000 kilometers. This means that the planet is more than 3,000 times bigger than its star. The star's density is about 23 grams per centimeter cubed, which is equivalent to the density of platinum. Scientists consider 1,438 bits to be a stellar remnant. Its outer layers have been forced out by a more massive pulsar, which has left its carbon trace. The bottom line is this combination of properties means that 1,438 bits is for all intents and purposes a diamond. Moreover, the planet orbits a pulsar at a very short distance. Now, isn't this truly fascinating? For the last 100 years, scientists have been observing a star from the Libra constellation that is 190 light-years away from us. This unusual heavenly body moves at an unbelievable speed of 1.3 million kilometers an hour. But more importantly, it is one of the oldest stars in the universe known to us. At first, the star's age was estimated to be about 16 billion years. But this calculation has caused a paradox to emerge. Why do you think that is? Being named after Methuselah, a 969-year-old biblical character and located in the Libra constellation, this star surpasses the age of the universe, which is about 13.8 billion years old. This means that this star is older than the universe by 3 billion years. But how is it possible, since it appears that the Big Bang happened after the star was created? Either the commonly accepted date of the Big Bang was incorrect, or the age of the star was a little exaggerated. But even considering the more accurate data on brightness, contents, distance, and the structure of Methuselah, a team of researchers has estimated its age to be 14.5 billion years, with an 800 million year error margin. The lowest limit of age shows that the star was created almost 13.7 billion years ago, which is hardly younger than the universe we imagined today. Hubble measurements enabled astronomers to specify the distance to the Methuselah star, or HD 140,283. By knowing the specific distance to the star, scientists were able to calculate the inner brightness of Methuselah needed to estimate its age. Moreover, they learned more about the burning speed, contents, and inner structure of the star, which also shed light on its probable age. For example, HG 140,283 has a relatively high ratio of oxygen to iron, which makes the age of the star lower compared to what had been assumed. The Methuselah star has one more special feature. It literally rushes through the sky, moving at the speed of about 1.3 million kilometers an hour, and every 1,000 years it moves by a width of a full moon. The most probable explanation for this is that this star was once a member of a dwarf galaxy, which merged with our Milky Way around 12 million years ago. It could have contributed to the way the Methuselah star moves across the sky as it returns to the bounds of the Milky Way. Well, let's see what other surprises the stars have in store for us. A triple star system, which was one day traveling through the center of our galaxy, has approached a supermassive object in the center of the Milky Way at a dangerously close distance. This has led to capturing one star and forcing the remaining two towards the galaxy's edge. Further down the road, these two stars merged into one, a super-hot blue star. Even though this course of events seems to be improbable, astronomers working with the Hubble Space Telescope confirm that such events might as well have taken place. They could have really created a superfast E0400 star will be sucked into the black hole, while its companion will be forced out. There is a black hole like that in the center of the Milky Way, and it is 2.5 million times heavier than the Sun. It could have actually accelerated E0400 and 375439. But here, astronomers faced the problem related to the fact that the time needed for the star to travel that far turned out to be more than 3 times longer than its age. The star has to be at least 100 million years old. However, its mass and the blue color indicate that it has been burning for the last 20 million years. Hence, the hellish racer star is too young to have come all the way from the galaxy center to its current location. Either the scientists are mistaken about the star's age and it's older than it seems, or it was born and accelerated in a different place. The brightest minds all across the globe are working to unravel the mystery of this star's phenomenon. Some phenomena are hard to explain. This story began in 2009 when NASA launched the Kepler mission in search for exoplanets. That is, planets outside the solar system. In particular, the satellite studied one region in the sky in the Cygnus and Lyra constellations of our galaxy. This area is marked with small squares. The satellite was registering the luminosity of over 150,000 stars for 4 years, recording data every 30 minutes. But how was it looking for planets in the first place? It was looking to catch a moment when a planet would pass between the telescope and the star, leading to a decrease in the star's luminosity due to a small portion of the stellar light being blocked. What you see here on the graph is a dip in the star's luminosity. This research method is called the transit method. But when looking for exoplanets, researchers found one of the most unusual mysteries of our universe. Let me explain what it is. To put this in perspective, I'll show you what a common graph of a star's luminosity looks like when a planet is detected by the transit method. Jupiter is the largest planet in our solar system. There are no planets that significantly exceed its size. A planet the size of Jupiter reduces the star's brightness by about 1%. If we're talking about Earth with a radius 11 times smaller than Jupiter, its signal on the graph will be barely distinguishable. Now, let's get back to our mystery. A group of researchers and enthusiasts looked through the data obtained by the Kepler telescope, striving to find new patterns, until they stumbled upon this. There was a strange signal coming from a star called KIC 8,462,852, located 1,480 light-years from the Sun. In March 2011, the star's luminosity dropped by as much as 15%. Just remember that even the largest planets cause a 1% drop in the star's luminosity. Transits usually last for several hours, but in this case, it lasted 1 week, and then the brightness came back to normal in a matter of days. In addition, the signal was asymmetrical, meaning that the object blocking the light emitted by the star wasn't round like a regular planet. That is, it's anything but similar to a regular planetary transit. Then nothing much happened until February 2013. It is then when the real madness began, the tabby star phenomenon. As I said, multiple dips in the light curve occurred, lasting for 100 days. Moreover, they all had irregular and unpredictable manner. Here you can see some examples of light curves at different time periods. One can easily see how much these curves fluctuate. They have different irregular shapes that don't resemble each other, as well as have different durations. At one point, the star's luminosity dropped by as much as 20%. This indicates that the object blocking the light was literally humongous. For example, its area should be 1,000 times larger than that of the Earth. What researchers needed to do is figure out what was wrong with this star and explain its behavior. The star was eventually named Tabby's star after Tabitha S. Boyajian, the lead author of the study that reported the discovery. A significant drop in stellar luminosity can be observed in young stars that still have a protoplanetary disk of gas and dust. It is this disk that can block the light, but Tabby's black hole, while its companion will be forced out. There is a black hole like that in the center of the Milky Way, and it is 2.5 million times heavier than the Sun. It could have actually accelerated He 437 But here, astronomers faced the problem related to the fact that the time needed for the star to travel that far turned out to be more than 3 times longer than its age. The star has to be at least 100 million years old. However, its mass and the blue color indicate that it has been burning for the last 20 million years. Hence, the hellish racer star is too young to have come all the way from the galaxy center to its current location. Either the scientists are mistaken about the star's age, and it's older than it seems, or it was born and accelerated in a different place. The brightest minds all across the globe are working to unravel the mystery of this star's phenomenon. Some phenomena are hard to explain. This story began in 2009 when NASA launched the Kepler mission in search for exoplanets, that is, planets outside the solar system. In particular, the satellite studied one region in the sky in the Cygnus and Lyra constellations of our galaxy. This area is marked with small squares. The satellite was registering the luminosity of over 150,000 stars for 4 years, recording data every 30 minutes. But how was it looking for planets in the first place? It was looking to catch a moment when a planet would pass between the telescope and the star, leading to a decrease in the star's luminosity due to a small portion of the stellar light being blocked. What you see here on the graph is a dip in the star's luminosity. This research method is called the transit method. But when looking for exoplanets, researchers found one of the most unusual mysteries of our universe. Let me explain what it is. To put this in perspective, I'll show you what a common graph of a star's luminosity looks like when a planet is detected by the transit method. Jupiter is the largest planet in our solar system. There are no planets that significantly exceed its size. A planet the size of Jupiter reduces the star's brightness by about 1%. If we're talking about Earth with a radius 11 times smaller than Jupiter, its signal on the graph will be barely distinguishable. Now let's get back to our mystery. A group of researchers and enthusiasts looked through the data obtained by the Kepler telescope, striving to find new patterns until they stumbled upon this. There was a strange signal coming from a star called KIC 8,462,852, located 1480 light-years from the Sun. In March 2011, the star's luminosity dropped by as much as 15%. Just remember that even the largest planets cause a 1% drop in the star's luminosity. Transits usually last for several hours, but in this case, it lasted 1 week, and then the brightness came back to normal in a matter of days. In addition, the signal was asymmetrical, meaning that the object blocking the light emitted by the star wasn't round like a regular planet. That is, it's anything but similar to a regular planetary transit. Then, nothing much happened until February 2013. It is then when the real madness began, the Tabby star phenomenon. As I said, multiple dips in the light curve occurred, lasting for 100 days. Moreover, they all had an irregular and unpredictable manner. Here you can see some examples of light curves at different time periods. One can easily see how much these curves fluctuate. They have different irregular shapes that don't resemble each other, as well as have different durations. At one point, the star's luminosity dropped by as much as 20%. This indicates that the object blocking the light was literally humongous. For example, its area should be 1,000 times larger than that of the Earth. What researchers needed to do is figure out what was wrong with this star and explain its behavior. The star was eventually named Tabby star after Tabitha S. Boyajian, the lead author of the study that reported the discovery. A significant drop in stellar luminosity can be observed in young stars that still have a protoplanetary disk of gas and dust. It is this disk that can block the light, but Tabby's star doesn't seem to be young. A second hypothesis attributes this luminosity drop to a large number of comets, but the problem with this version is that there must be quite a lot of comets. Perhaps 1,000, maybe even tens of thousands of comets to have such an effect, according to the study by Muhammad Sheikh, Richard Weaver, and Karen Dolman from the University of Illinois at Urbana-Champaign, published in 2016. The avalanche statistics associate the mysterious fluctuation in the star's One of the recent hypotheses that gets the most traction is that dark matter, which lurks near almost every galaxy, is at fault. Presumably, it could provoke acceleration and extreme heating of regular intergalactic space matter, thereby depriving the galaxy of building materials necessary to form new stars. Let's take one more step in our journey, and by step, I mean moving over 9 billion light-years deeper in outer space. NGC 1277 galaxy was first discovered in 2018 by the Hubble telescope. It is 240 million light-years away from Earth. In the case of MAC S2000 129-1, we could only see the galaxy's condition 10 billion years ago, with no way of knowing what happened to it up to the present moment. Here, the reverse is true. The galaxy is relatively close, and scientists can say for sure that it has not formed new stars in the last 10 billion years, effectively rendering it dead. But of course, this was not always the case, and from what we know, its young years were quite crazy, to say the least. Researchers argue that following the galaxy's formation, new stars lit up 1,000 times faster than they do now in our Milky Way. Such a formation rate is absolutely inconceivable. In short, our galaxy produces the equivalent of 3 solar masses of new stars per year. That's an average of 1 or 2 stars, while NGC 1277 spawns many hundreds and even thousands of stars per year. But these dates are far behind, specifically about 10 billion years ago on a universal scale. NGC 1277 can be seen as a precautionary tale of the Earth's jungle law in action. Galaxies also have to make a choice between devouring their peers or dying. NGC 1277 chose the latter. Scientists are almost unanimous on what caused this galaxy's untimely death. NGC 1277 is moving too fast. It rushes through the Perseus galaxy cluster at a speed of about 3.2 million kilometers per hour and cannot gain mass by feeding on the intergalactic matter or smaller clusters. Another thing that led NGC 1277 to its sad fate is the dangerous route it moves, not far from the Perseus cluster center, which has quite an unfavorable environment. The intergalactic gas is too hot to form the building blocks for new stars. Metaphorically speaking, NGC 1277 died of starvation and exhaustion. For the same reason, the galaxy couldn't fully form. Astronomers even call it a galaxy with arrested development. NGC 1277 has twice as many stars as the Milky Way, but is only a quarter of our galaxy's size. Yet another surprising thing about NGC 1277 is an enormously massive black hole in its center. It might be fully or at least partially responsible for the galaxy's rapid burnout. But for all the massiveness of this black hole, it is a far cry from another monster lurking in the center of M87. Another dead galaxy. It's time we pay it a visit. The galaxy is located approximately 53 million light-years from Earth. Although it is insanely far away, it is virtually a stone's throw from us when compared to the distance of the Mach S 2129-1. The relative proximity and gigantic size of the galaxy contributed to its early discovery in 1781 by the French astronomer Charles Messier. The letter M in the name indicates the discoverer's name. According to the New General Catalogue's classification, the object is called NGC 4486. The galaxy is observed at the upper border of the constellation Virgo, just below the constellation Coma. If we held an intergalactic competition, then M87 would take prizes in several nominations at once. This galaxy is the largest in the constellation Virgo, the second brightest in the cluster of the same name, and one of the most massive in the local supercluster of galaxies, which is also called the Virgo supercluster. M87 belongs to supergiant galaxies. It reaches 120,000 light-years in diameter. This is slightly larger than the Milky Way's radius, but the galaxies are by no means similar. M87 is not a flat spiral but a sphere, weighing a whopping 2.7 trillion solar masses. According to various estimates, the total mass of M87 may exceed the Milky Way by 200 times, with about 12,000 clusters against our 150 to 200. It also surpasses our galaxy by almost 2 orders of magnitude in terms of the number of globular star clusters. However, all this massiveness and abundance of stars do not change anything in terms of whether the galaxy is dead or alive. The star formation has virtually ceased, meaning that M87 is dead. What brought the galaxy to its demise is the infamous overheating, which was often observed for many thousands of light-years around. It was these amazing formations that allowed us to see the mysteries hidden in the pitch-dark space. Magnetars are amazing outer space creatures. One can almost aptly characterize them with the word extreme, especially in the most unexpected and paradoxical senses of the word. By cosmic standards, magnetars are absolutely tiny. Don't forget that these are actually stars, albeit former ones. If the Sun has a diameter of 1,392,700 kilometers, then magnetars are only 20 to 30 kilometers, not 6 or 4-digit numbers, mind you, just kilometers. Considering their humble size, their mass is enormous. Most of them are much heavier than the Sun. This is why magnetars' density, like that of other neutron stars, is beyond any stretch of imagination. The value will say little even to a savvy person since such whopping numbers are hard to comprehend. Popular science gives the following analogy. A spoon of such a substance in a stable state would weigh hundreds of millions of tons on Earth. To put this into perspective, Burj Khalifa, the tallest skyscraper in the world, weighs only 500,000 tons. Another impressive point is the rotational speed of this type of neutron star. Most of the known magnetars revolve around their axis several times per second. While being so bizarre, magnetars are at the same time the shortest living space objects with a lifespan of 1 million years or less. The active phase of the magnetar's life cycle doesn't exceed 10,000 years, which is followed by the magnetic field decay and a sharp decrease in radiation power. A magnetar is a one-day butterfly by space standards. Since magnetars are extremely rare, we only know 30 objects of this kind. 24 are generally recognized in the scientific community, while the remaining 6 are yet to be confirmed. Magnetars don't vary as much in terms of mass, shape, size, and other characteristics of mature stars. Therefore, the number of bizarre features discovered is directly proportional to the depth of the study, and that in turn is due to these objects' proximity to Earth. The closest known magnetar, called 1E2000, 259 plus 586, was discovered in 1981, long before scientists created magnetar theory. It lies 13,000 light-years away from Earth in the Cassiopeia constellation. It's no more than 20 kilometers in diameter and revolves around its axis every 6.98 seconds, which is very slow by neutron star standards. It is the source of soft recurrent gamma-ray bursts, yet the word soft may sound misguided. This is just a characteristic. Soft gamma radiation is generated during energy transitions inside atomic nuclei, while hard radiation is emitted during nuclear reactions. These soft gamma rays can be powerful enough to cause big trouble, and we'll go into more detail on this in a moment. Typically, when we think about a space threat, we tend to consider only objects close by, an asteroid fall or a super powerful solar flare in the worst-case scenario. But how can something tiny by universal standards, lying tens of thousands of light-years away, really harm us? It turns out, it can. The potential threat of magnetars to the Earth is shown by real incidents. These cases bring us back to the very first studies of these phenomena, when the term magnetar wasn't around. On March 5, 1979, at 10:51 North American Eastern Time, two Soviet Venus mission spacecraft, Venus 11 and Venus 12, recorded an intensive gamma radiation burst. From the usual 100 pulses per second, it skyrocketed to 200,000. The frequency increased dramatically in just a fraction of a millisecond. 11 seconds later, NASA's Helios I probe orbiting the Sun registered a second flare. In a few minutes, it also reached Venus, where it was registered by the American probe Pioneer Venus Orbiter. A few seconds later, a powerful radiation wave reached the Earth and was identified by the Vela satellite's detectors of the U.S. Department of Defense, the Soviet satellite Prognoz 7, and the Orbital Einstein Observatory, HEAO2. The international comet researcher then registered the outburst before it left the solar system. This event was the most powerful extrasolar gamma-ray emission ever recorded. It turned out to be over 100 times more intense than any extrasolar gamma-ray burst known before. The culprit was quickly identified with 2 arcsecond accuracy. It turned out to be the remnants of a massive star in the Large Magellanic Cloud, which exploded in a supernova around 3000 BC. The object was named SGR 052566. A distance of only 165,000 light-years saved humanity from some big trouble. A similar event in the early 2000s turned out to be equally or even more powerful. A sharp and powerful stream of which is more than the Sun emits in 100,000 years. If SGR 1806 lay at the distance of the nearest star, Alpha Centauri, which is about 4 light-years away, it would take a split second for this enormous gamma-ray wave to wipe out all complex life on land and in the upper layers of the oceans. The SGR 1900+14 magnetar, located merely 20,000 light-years away, even forced NASA to shut down the near-Shoemaker automatic interplanetary station sent to the asteroid Eros in 1998. The gamma-ray burst could have easily destroyed the device. Our only consolation is that all the known magnetars are at a fair distance from the Earth. Only here the word known sounds slightly alarming. Pan is the innermost known moon of Saturn that looks like a giant cosmic ravioli. It is 28 kilometers across and orbits 134,000 kilometers from Saturn, within the Encke gap within the planet's A-ring. Pan is 541.8 times smaller than Earth. This space body was discovered by Mark R. Showalter in 1990 using images taken by the Voyager 2 spacecraft 9 years earlier. Since Pan orbits Saturn every 13.8 hours, it acts as a shepherd satellite and is responsible for keeping the Encke gap in Saturn's A-ring open by gravitationally pushing the ring particles back. As they go beyond, the image shows the summit side of the ring from a height of approximately 38 degrees above the ring's plane, about 3.2 million kilometers away from Pan. We see the unusual bizarre shape of Pan's northern and southern hemispheres in these stereo images. Just to put this in perspective, the photos taken from NASA's Cassini spacecraft show how the viewscape has shifted at a distance of 24,600 kilometers from Pan. This was Cassini's closest encounter with it, which showed the small moon in detail and 8 times better compared to previous observations. In the photo, we also see a ridge around the lunar equator which rises for about several kilometers. The ridge is most likely a pile of ring dust that fell on the moon as it cleared the Enki gap. Something no less strange than Pan is hiding from us near the Virgo constellation. Something that looks like a giant Mexican hat. The Sombrero Galaxy, or M104. It is a spiral galaxy at the border of Virgo and Corvus constellations. Because it can only be observed from the side, we see it as a flat pancake. The Sombrero Galaxy's diameter is approximately 49,000 light-years, which is over twice less massive than the Milky Way. It's about 31 million light-years away from our galaxy and 800 billion times heavier than the Sun. The galaxy is one of the most massive objects in the Virgo galaxy cluster. M104 was discovered back in 1781 by the French astronomer Pierre Méchain. This stunning image of the Sombrero Galaxy is one of the largest patchwork pictures obtained by Hubble. What stands out is its shiny white bulbous core surrounded by thick dust strips that make up the galaxy's spiral structure. The photo shows many light points scattered across the convex part, which actually form globular clusters. They make the galaxy look like a sombrero hat. The galaxy's dust and inner flat disk are easily seen in the infrared range. At the center of M104, scientists have discovered a black hole with a mass exceeding 1 billion solar masses. It actively devours matter that accidentally crosses its path. Another study of the Sombrero Galaxy in 2012 found out that it consists of one galaxy nested in another, meaning that it has a kind of bifurcation where a large elliptical galaxy contains a smaller disc-shaped galaxy. Such amazing combinations of two objects are hard to come by in the universe. They are as rare as giant planets with a mass comparable to that of the plastic foam. Celt 11 Bits is a gas giant exoplanet orbiting a G-type star in the Leo constellation. Its mass is 0.171, that of Jupiter. It's so close to its parent star that it takes the planet only 4.7 days to orbit it. The discovery of Celt 11 Bits was announced in 2017. This planet is only 20% lighter than Jupiter, but at the same time it is almost 40% larger. All this points to the fact that Celt 11 Bits is almost equivalent to polymeric foam in terms of density. In addition to its unusual density, what sets Celt 11 Bits apart is that its host star is extremely bright. The star called Celt 11 is gradually transforming into a red giant. This means that it began to consume its nuclear fuel by melting hydrogen in a shell outside the core. Scientists predict that over the next 100 million years, the outer layers of the parent star formation is accompanied by radiation and winds that destroy their birthplace, eventually causing the Witch-Head Nebula to disappear. In an image from NASA's WISE Wide-Angle Infrared Research Probe, the witch appears to be screaming out into space. The bright blue color of the nebula is due not only to the star's hue, but also to dust particles reflecting blue light more efficiently than red, a similar physical process that causes the Earth's daytime sky to appear blue. An interesting tidbit is that the nebula was used in the Andromeda TV series as the site of a major space battle that threw civilization into an era of chaos. Moving on from war to more pleasant things, let's talk about fragrant raspberries and strong rum, and their connection to space. Astronomers made an incredible discovery while studying Sagittarius B2, a dust cloud located 390 light-years from the Milky Way's center. They detected ethyl formate, which coincidentally is the dominant flavor in raspberries as well as in rum. Also, when using spectroscopy to study Sagittarius B2, the cloud was found to be composed primarily of alcohol, but not the kind found in alcoholic beverages. Rather, it's a mixture of methanol, ethanol, and other substances. The supermassive black hole in the lenticular galaxy Centaurus A, located 10 to 16 million light-years from Earth, weighs about 55 million solar masses, and is one of the closest black holes to the Milky Way. It absorbs matter and pushes out a relativistic jet, with X-ray jets thousands of light-years long and radio jets over 1 million light-years long. Despite being invisible to the naked eye, data obtained in different ranges of electromagnetic waves allow us to still enjoy this stunning sight. Now, let's explore a further frontier over 2 billion light-years away from Earth. In 1959, the British astrophysicists from the Cavendish Group discovered a supergent elliptical galaxy, 3C 348, using the Cavendish Observatory's Cambridge interferometer. This galaxy is over 1,000 times more massive than our Milky Way, with a central black hole almost 1,000 times more massive than the Sagittarius A** black hole in the center of our Milky Way. It is one of the largest black holes known to date. The galaxy's active nucleus has been recorded, including jets of matter and powerful X-rays emanating from its center, likely originating from matter ejected perpendicular to the accretion disk of the central black hole. Spectacular images show relativistic jets ejected by a giant black hole and turbulent eddies at their ends. The next intriguing object, just near NGC 6426, is a quasar, an incredibly powerful engine on a universal scale. Quasars are active gigantic nuclei with supermassive black holes at their center, showcasing phenomena such as the ejection of relativistic jets at a super-large and luminous scale. This specific quasar is incredibly bright and situated at an unimaginable 2.44 billion light-years from Earth. Its great luminosity overshadows the entire galaxy with its hundreds of billions of stars. Moving to a distance of 6 billion light-years from Earth, another dazzling quasar is driven by a gigantic supermassive black hole, rotating at about half the speed of light. This black hole is observed in the Crater constellation, and the image is enhanced and magnified by the gravitational lensing effect created by the total gravitational field of a lenticular galaxy in the center of this bright circle. The quasar is displayed in pink according to the Chandra observatory data. Overall, our short journey through these remarkable astronomical discoveries has come to an end, but the era of space discoveries is in full swing. Promising astronomers will continue to excite us with stunning and detailed images of unusual space objects in the near future.